This hydrogen atom has one electron in its outermost shell, but this outermost shell holds two. So this hydrogen atom needs one electron to fill its outermost shell, which is a more stable configuration. So hydrogen atoms react with each other to form the gas H2, in which each hydrogen atom shares one electron with the neighboring hydrogen atom, so that each possesses two electrons around it at least some of the time. This is an example of a single covalent bond because one electron is shared by each atom. Each of these oxygen atoms possesses 6 electrons in its outermost shell, but the outermost shell fits 8. So each oxygen atom requires 2 electrons to fill its outermost shell. When oxygen atoms react with each other, they do not share 1 electron each, because this would not give them a sufficient number to fill their outermost shell. Each oxygen atom donates 2 electrons to the shared bonds to form double covalent bonds, in which each atom shares 2 electrons, and this allows for each atom to have 8 electrons in its outermost shell, at least some of the time. So oxygen gas, O2, forms when oxygen atoms form double covalent bonds with each other. Each of these nitrogen atoms possesses 5 electrons in its outermost shell, but the outermost shell can fit 8. And so each of these nitrogen atoms requires 3 electrons to fill its outermost shell. When nitrogen atoms react with each other, they form triple covalent bonds, in which each atom shares 3 electrons with its neighbor. This is a very strong bond, and thus nitrogen gas, N2, consists of 2 nitrogen atoms which are bound through triple covalent bonds.